Okay. How do you subtract two fractions? You have to have a common denominator? Right, so we have to have a common denominator. Guys, hey, you know what'll make your life easier? If you simplify 4 and 6 first. What's 4 divided by 6? Okay, so now, to have a common denominator, are you going to think to do that? If you don't think you'll think to do that, let's work it as if we didn't do that. Okay. What do both 3 and 6 go into? No, what do they both go into? Well, 6, right? Yes. Okay, so they both go into 6, so all I need to multiply 3 by to get 6 is what? 2, so I'm going to multiply top and bottom by 2. Now this is a 6b, this is just a 6, so what do I need? Okay, so what do I do with this 2? So distribute it? Okay, so 2a plus minus over the common denominator what? What's 10b minus 4b? 6b, so I've got 2a plus 6b over 6b. Do those cancel out? No, they don't. Why don't they? Because it's plus. If it's not multiply, they don't cancel out. Now, however, they're all divisible by what? 2, so I could divide everything by 2. If I divide everything by 2, what am I left with? A plus 3b over 3b. That's what we just said. You can't cancel out 6b's because it's addition, not multiplication. So the only thing I can do is divide everything by 2. A plus 3b over 3b. And there's my final answer. Now, if I had done just a 2 and a 3, then the only thing I would have had to multiply is b, right? So I would have a plus 5b minus 2b over 3b. You just get to the answer more quickly. Okay? Alright, so what about 55? Do they have a common denominator? Right. This one, yeah. Let's simplify this one. What's 6 divided by 2? 3? 3 over 1 or just 3? So that's just 3x. What's 6 divided by 3? 2. And what's x divided by x? Guys, what do the x's do? They cancel out. So I'm just left with 3x minus 2. Am I done? Yeah, I'm done. Now, if I hadn't recognized this, then you would have said that the common denominator is, what did 2 and 3 both go into? 6, so you'd have multiplied this by 3. And then I need an x, right? Well, on this side I still need a 2. So I would have had 18x squared minus 12x over the common denominator, 6x. But do you notice how all three of them are divisible by 6 and x? So 18 divided by 6 is 3, x divided by x, x squared divided by x is x. 12x divided by 6x is just 2, and then 6x divided by 6x is 1. So we're done. Okay? Took a little bit longer though. Okay, so what about 56? Do they have a common denominator? No, so what do they need? Each other. Okay, so if the denominators have nothing in common, then they need each other. So on this side, I'm going to multiply by what? Okay, on this side, I'm going to multiply by what? Okay, so now what do we do? Now what do we do? Okay, so 5p times p. 5p squared minus 15p plus over the common denominator You don't have to FOIL it out. You can just leave it like that, that's fine. Now, is there anything you can combine? Negative 15p and 30p is just a positive 15p. So my final answer is 5p squared plus 15p plus 6 over this, the denominator. Okay. Okay, so what do I need to do with 57? Right. Do they have a common denominator? So we multiply by each other. Okay, and then on this side I need 2x plus 1. How is this problem slightly different from the last one? It's subtraction. What do you have to remember to do? Alright. You have to distribute that negative 6, not just a 6. So when I distribute this, I've got 3x times x is 3x squared. 3x times negative 5 is negative... Okay. I'm going to distribute a negative 6. So negative 6 times 2x, negative 12x, and then negative 6 times positive 1. Good. Over the common denominator of... Okay. Is there anything you can combine, guys? What's negative 15 and negative 12? Negative 27x. Okay. We good? Okay. Let me move this out of the way. Okay, so now let's do 58. Okay, guys, do these have a common denominator in the top? Yeah. So can we go ahead and add them? Right, so let's go ahead and add x minus 3 and positive 1. X minus 3 plus 1 is just x what? Minus 2 over the common denominator. Over, which is over an understood 1. And the reason I did that is because when you divide a fraction by another fraction, what do you have to do? So we flip and multiply. So 1 over, yes you did. So 1 over x minus 3. Does anything cancel out? No. So my final answer is just going to be x minus 2 over x times x minus 3. Now you could distribute x squared minus 3x, but that's it. Okay, do these have a common denominator? Nope, so what would you do? What would be common between a squared and 2? Both of them? So what do you need on this side? 2. What do you need on this side? A squared? Okay, so now do they have a common denominator, 2a squared? Okay, so what's the numerator? Okay, over the common denominator what? Over, which is over. Okay. So, right. I'm going to flip and multiply by 1 over 6. Now, those cancel out, but does anything simplify in the numerator and the denominator? Okay, I'm thinking no. So 4 plus 3a squared over what? Times 6? Which is? There you go. Nah. I know what you're thinking, but yeah, in this case it was simple. Okay, so now let's go to these. If you have your power chart, it'd be nice to go ahead and get it out. Otherwise, I'll write down some notes for you. Okay, square root of 27. 27 is not doesn't have a perfect square, right? Okay, so what perfect square goes into 27? 9, right? The square root of 9 is 3. So I got 9 times 3b. What's the square root of 9? So I put a 3 on the outside. What do I leave inside? And there you go. Right. Okay. So let's look at 61. Okay, is there a perfect square that goes into 63? No, I think so. I'm thinking 9. 9 how many times? What's the square root of 9? So that goes on the outside, and then 7 stays on the inside. What's the square root of v squared? Just v. Do y'all remember doing that? The understood power or root is 2 right there, right? How many times does 2 go into 2? Once. Plus you just got to remember that the square root squared cancel each other out, right? Okay. So that's why the v is on the outside and then it's not on the inside. Guys, what if it had been the square root of, so we have 9 times 7, and it had been v to the 5th. What's the square root of 9? And I'll leave the 7 on the inside, right? So then you ask yourself, how many times does 2 go into 5? 2 times with 1 left over. So I remember doing that? Okay. So now let's do these. This is the what root? Third root? So you know what you need to look at? Not powers of 2 now, powers of 3. So what is 2 cubed? 8? 2 cubed is 8. You can look at your power chart, guess. What's 3 cubed? What's 4 cubed? 5 cubed? Does 125 go into 250? How many times? So this is going to be the cubed root of 125 times 2. M to the 4th, n to the 4th. Okay, so what is the cubed root of 125? Well, if 5 cubed is 125, then the cubed root of 125 is 5. So the cubed root of 125 is 5. What stays on the inside? The 2. And then I ask myself, how many times does 3 go into? 4, right? 1m with how many left over? 1. You don't have to put the powers of 1, but I am. And then I ask myself, how many times does 3 go into 4? Once with, and there you go. Okay? So now let's look at 63. What am I looking at now? Powers of what? 6. What is 2 to the 6th power, guys? What's 3 to the 6th power? Well, that's way too big. So the only option I have is 64, yeah? Does 64 go into it? I'm thinking 3 times, yeah? 64 times 3, m to the 4th, n to the 7th. Okay, what is the 6th root of 64? 2. Since 2 to the 6 equals 64, the 6th root of 64 is 2. So I've got a 2 on the outside. What's on the inside? Yeah? Okay, what do I ask myself as far as the powers go? How many times? How many times does 6 go into 4? It doesn't. 4 goes into 6. Maybe you're thinking 2s, I don't know. Yeah, it's the power of 4. M to the 4th power. Okay, how many times does 6 go into 7? Once with 1 left over. Okay, do me a favor on the next one. Make this b to the 10th and c to the 14th. It's a little boring otherwise. We're good. Okay, so we're looking at powers of what? 7. So what is 2 to the 7th? What is 3 to the 7th? That's too big. That's definitely not going to go into that. So my only choice is divide by 128. So you divide by 128 and you get what?
6.
I think it's 8. Okay. What's the 7th root of 128? 2. That's the whole point of doing this, right, guys? The whole point of finding this number is to be able to say if 2 to the 7th is 128, then the 7th root of 128 is 2. That's the whole point. So this is 2, and then I leave what on the inside? 8. Okay. And then I ask myself, how many times does 7 go into? 6. Okay, so that stays inside. How many times does 7 go into 10? Once with 3 left over. Ooh, I put a 10. It's a 3. That is a terrible 3. Okay. And then how many times does 7 go into 14? No left over? So we're done. With that one. Okay, what am I looking at? Powers of what? Powers of 4. So 2 to the 4th is 3 to the 4th? 4 to the 4th? That's too big. So first I would divide by 81, and I'm pretty sure it's 81. Because 8 times 3 is 24, and 1 times 3 is 3. So the 4th root okay, so what's the 4th root of 81? 3. So then I've got the 4th root with what left over on the inside? We took care of that, right? What's left on the inside? The 3. Okay, I asked myself what, guys? How many? 1 left over? Okay. For J? Okay. And then you said K is once with 3 left over? Alright, there we go. Yep. They're actually pretty easy. So we'll just talk about it. You good, Dalton? Okay. Let's just review for a second, guys. What is the square root of 3 times the square root of 4? Sorry, let's do square root of 5. What's the square root of what?
15.
Square root of 15. What's the square root of 3 times 5? 5 square roots of 3. You can't multiply them with each other, right? You just have to multiply them, like, you can't multiply 5 and 3, right? Because one's on the outside, one's on the inside. So what if I said, what is 5 square roots of 3 times 2? 2's on the outside. Good. So then, what is 4 square roots of 3 times 6 square roots of 5? And there you go, yeah? What is 3, square root of 3 times, let's say 5 square roots of 3 times the square root of, let's do, sorry, I'm thinking. I'm thinking! Let's just do 15. Okay, what can I multiply?
That's five.
Can you simplify the square root of 45? No? 49 is what you're thinking. Is there a perfect square that goes into 45? What's the square root of 9? So, once you simplify, sometimes you have to simplify further using the fact that you have a square root now, a perfect square. Okay? Alright, so now let's do these problems. Okay, so we're on 66, yeah? When I multiply these two, what can I multiply? The 2 with the what? Well, first we're going to distribute, yeah? So I've got 2 square roots of 15 times the square root of 3. Can I multiply 2 by anything? Or is it just a 1? So that's just a 2, and then I've got square root of 15 times 3. Square root of plus 2 square roots of 15 times 4. What can you multiply when you say 2 square roots of 15 times 4? 4 and 2 is, and then square roots of, okay, are we done? We just looked at this. Square root of 45 is, it's okay, so what's the square root of 9? And then 5 stays inside it, right? So what is that really? So my final answer is going to be 6 square roots of 5 plus 8 square roots of 15. So this is 6 square roots of 5 plus 8 square roots of 15. Yep. Is there a perfect square that goes into 15? No, the only perfect squares are 1, 4, 9, 16. So 4 and 9 don't go into it, so we're done. Okay, so what about this one? What do you multiply? So 2 square roots of 15 times 5. Do you multiply 2 and 5 or 15 and 5? 2 and 5 is what? So 10 square roots of 15. Now I multiply what? 2 square roots of 15 times 3 square roots of 5. So when I do this, I've got 2 times 3, which is 6, and then square root of 15 times 5 is square root of 75. Does 75 have a perfect square in it? You sure? The perfect squares are 1, 4, 9, 16, 25. How many times? What's the square root of 25? So when I bring a 5 on the outside, I'm going to multiply by what? By 6, making that 30 square roots of 3, right? And there we go. Okay. So 68. I'm going to distribute again, right? Square root of 6b times square root of 3. Square root of 18b. Minus square root of 6b times 5 square roots of 2b. What do I do with 5? Just put it in the front. So I've got 5 square roots of 6b times 2b. 12b squared. Okay, we got quite a bit of simplification to do on this one. Is there a perfect square that goes into 18? 6 and 3 don't take a square root. 9 and 2. What's the square root of 9? Okay. What about 12? What perfect square goes into 12? Okay. Can I take the square root of b squared? Right? Isn't there an understood 2 right here, guys? So how many times does 2 go into 2? Once. Or just think, what's the square root of b squared? Square root and square root cancel each other out, so it's just b. So I've got the square root of 4, which is what? 2. The square root of b squared is b, and then I'll leave a 3 on the inside. Yeah? So then, I just simplify that to what? 10. So I've got 10b squared roots of 3. Oop, that's a 3. And there we go. Okay. You don't have to write the power or the root of 2. That's an understood square root. Okay, now the reason I wrote the 2 is because I wanted to emphasize what we just did. How many times is 2 going to 2? Once. Okay. Okay, 69. When we multiply these two, 4 square roots of 15n times 3, what do you multiply? Times, and that is, so I've got 12 square roots of 15n plus 4 square roots of 15n times the square root of 10. 15 times 10 is 150, and then there's an n, right? Okay. There's not a perfect square in 15, right? We've done that a couple times. But is there a perfect square in 150? I'm thinking 25. How many times does 25 go into 150? What's the square root of 25? So that's ends up being 20 square roots of 6n. We good? Okay. We've only got a couple more, yeah? Okay. The square root of x minus 3. Okay, do you remember just graphing square roots? At 0, 0, the square root of 0 is 0. The square root of 1 is what? What's the square root of 4? And the square root of 9? 3. What's the square root of negative numbers? Imaginary, which is why it doesn't exist, right? So what transformation are we doing right here? We're shifting where? To the right, 3. So it starts at 3. Now, if you don't know exactly how to sketch this, then you type in your y equals, and then you go to the table, right? Well, so it'll start at 3. It'll say at 3 at 0. So you might want to do that, guys. Make sure that you know how to type in y equals and look at your table. Tito? Michael? Y equals? Uh, 3 equals 0, 4 equals, and 7 equals, and that's really all you can see. And if you look at your graph, it just does that, right? Now, guys, it also asks you to identify the domain and the range. Domain, it represents x or y? X. So look at the x-axis, guys. On the x-axis, what's the farthest to the left it goes? 3. Do we actually reach 3? Yeah. So we put a bracket, and then we go all the way to what? Okay. Range is y, yeah? So look at the y-axis. What's the lowest this goes on the y-axis? 0. And it goes up to? And there you go. Nope, just infinity. Okay. What about this one? Right, you just take the function, shift it up 2. So if I go, if it at 1, it'll be at 3. At 4, it'll be at 4. And that's all you really can see. At 9, it would be at 5, but you can't really see that. So it would just do this. Wait. Oh, hey. She's still not here. They misspell my name every single time. They put an I at the end, and I've told them over and over, it's a Y. And now I just complained on video. That's silly. Okay, so let's do domain and range. Domain is x, yeah? What's the farthest to the left we go on the x-axis? 0, and then we go all the way to infinity. Range is y, so what's the lowest we go? 2, and we go up 2. And there you go. Is that all you have on yours?
Yes.
So we're done?
Yes.
How exciting.
You want this one?
Yep.
All right, here you go.